we're going to take a look at the last of our converse theorems for parallel lines, which would be the consecutive interior angle converse theorem. Interior angle converse theorem. So the consecutive interior angle converse theorem, just like converse theorem, just like my initial consecutive interior angle theorem, obviously talks about consecutive interior angles, but also talks not about congruency, but talks about supplementary angles. So what this says is instead, I'm still trying to prove the lines parallel, but it says that if the consecutive interior angles are supplementary, then the lines are parallel. Oh, parallel. Okay, so just like before, I'm going to start off with my diagram with two lines here that look like they're parallel, but we don't know what they are, and they're going to be intersected by a transversal. But now this time, after I label my angles, what I'm going to end up talking about are the consecutive interior angles, so something like 4 and 5 or 3 and 6. And instead of them being congruent, they're going to be supplementary to each other. So what I'm trying to prove is that given, so either of these pairs, let's go with 4 or 5, given that angle 4 is supplementary to angle 5, what I want to prove is that the lines are parallel, and I never named them, so this is P and Q and then T. So P is parallel to Q. So my proof is going to look a little bit different than the other ones, and that's fine. But I'm going to end up linking together some supplementary angles here. But my goal is still to talk about a pair of corresponding angles that are congruent. So before I put too much thought into it, let me write down my given. So angle 4 is supplementary to angle 5. That is given. Okay, so if I'm trying to prove that, or given that angle 4 and angle 5 are supplementary, I'm trying to get to a pair of corresponding angles that are congruent. Since I'm talking about 4 and 5, let's pick 5 for example. The corresponding angle to 5 is 1. If I can show that angle 1 and angle 5 are congruent to each other since they're corresponding angles, then my lines will be parallel. So the question is how I can do that. And if I know that 4 and 5 are supplementary, I also know that 4 and 1 are supplementary because they are a linear pair. And what I know about two angles that are supplementary to the same angle, that's going to make them congruent. That's my congruent supplements theorem. So that's actually going to be my structure for this proof here, is that if I'm trying to link together 1 and 5, since they're corresponding angles, I can do that by saying 4 is supplementary to 1, and I was given that 5 is supplementary to 1. So that's how I'm going to work through this. So step number 2 here will be to talk about 1 and 4. I want to say they're supplementary. Before I do that, I need to say that they're a linear pair. So I can say that angle 1 and angle 4 are a linear pair. And the reason for that is just assumed from diagram. And then what I can immediately say is that angle 1 is supplementary to angle 4. And the reason for that is I can use my linear pair postulate. It says that if two angles are a linear pair, then they are supplementary. Then they are supplementary. All right, and that came from statement number 2. Okay, so before, what I would have to do if I had these angles that are supplementary to the same angle and I wanted to end up talking about congruence, I'd have to do all this stuff about, converting these into equations that I can end up linking together. But fortunately, what I have is this theorem that we proved earlier, which is the congruent supplements theorem. And so what it says is that if two angles are supplementary to the same angle, in this case, angle 1 is supplementary to angle 4, and angle 5 is also supplementary to angle 4, that means that these two angles will be congruent to each other. So I can jump straight to that. So this actually ends up being just as easy of a theorem to prove as the other ones were. Wasn't as much work as the consecutive interior angle theorem. But we can say that angle 1 is congruent to angle 5, and it is the congruent supplements theorem. If two angles are supplementary to the same angle, the same angle, then they are congruent. Are congruent. Perfect. Okay. And so that was linking together statements 1 and 3. And so now that I know that angles 1 and 5 are congruent, since they are corresponding angles, I'm going to link this back to my corresponding angle converse postulate, which says that if the corresponding angles are congruent, then the lines are parallel. And so I'm basically done. I can just say that statement number 5, P is parallel to Q. Use my corresponding angle converse. If the corresponding angles are congruent, then the lines are parallel. So this ended up being not that bad of a proof, even though we were talking about supplementary angles, and the reason for that is that we were helped out by this congruent supplements theorem, which made everything easier for us. We didn't talk about measuring anything. So now we know, though, that if angle 4 and angle 5, in this case, they are consecutive interior angles, if the consecutive interior angles are congruent, then the lines will have to be parallel, and we can use that moving forward.